What is discussed here is how spectroscopic parallax is used to find distances to stars. Though the method contains the word parallax, it is not directly related to the parallax method discussed previously. It should also be noted that this method only works for main sequence stars. Recall that if one has a way to determine the absolute magnitude of an object, i.e. its luminosity, and one has measured the apparent magnitude, i.e. the flux, then one can use these two quantities to calculate the object's radial distance. Spectroscopic parallax gives us one way to determine absolute magnitude by relating the main sequence star's absolute magnitude to its surface temperature. The main sequence line on the Hertzsprung-Russell diagram is basically a graph of this relationship. What is required is a calibrated main sequence line. To do this, we need to work backwards. We need to determine what the absolute magnitudes are of stars with different temperatures. This means we need stars close enough so that their distance could be measured using parallax. The Hyades cluster is a nearby open cluster of a few hundred stars. The distance to Hyades was measured using parallax. The apparent magnitudes and temperatures of its stars were also measured. The absolute magnitudes of those stars were then calculated using their apparent magnitudes and distance. Once one had absolute magnitude and temperature, the data could then be plotted on the Hertzsprung-Russell diagram, establishing a calibrated main sequence line. Once one has a calibrated main sequence line, then it can be used as a tool to determine the absolute magnitudes of other stars given their temperatures and apparent magnitudes. Recall that temperature can be represented in degrees Kelvin, or by BV color index, or by spectral classification. In the example shown, assume that the BV index of a star was measured to be about 9.3. One would locate that index along the horizontal axis. From there, go straight up to the main sequence line. That is ideally where the data point for this star would be plotted. From there, move left horizontally to read the absolute magnitude off the vertical axis. In this case, it would be about 6.8. One can use the equation shown at the bottom, inverse square law, to calculate the distance in parsecs. Suppose the measured apparent magnitude was 18.0. Plugging in 18.8 for the apparent magnitude and 6.8 for the absolute magnitude, one obtains the distance of 1,738 parsecs. The spectroscopic parallax method is good out to about 100,000 light-years. This then allows us to find distances to objects out to about the diameter of our galaxy.